Welcome to this explainer. Today, we're diving straight into a fascinating digital crime scene to figure out exactly why artificial intelligence absolutely breaks down when you explicitly tell it not to do something.
Okay, let's kick this off with a classic psychological trap. I want you to listen to this instruction very carefully. Whatever you do right now, absolutely do not think of a white bear.
So, be honest, what did you just picture? Because if you're like pretty much every other human on the planet, that white bear just crashed right into your active mind despite your absolute best efforts to suppress it, right? You were given a direct command to avoid a thought, and well, it practically guaranteed you'd think of it. To understand why both we and our highly advanced AI mathematically fail this exact same test, we first need to look at how human cognition actually works.
Section 1. The Human Mind, Global Workspace Theory.
You see, our brains process thousands of things quietly in the background all the time, like managing your posture or, regulating your breathing. But the moment a forbidden thought is mentioned, like our friend the white bear, it is forcefully dragged into this momentary, highly active shared mental workspace. And once it's broadcast there, it simply cannot be ignored.
Section 2. The AI Mind, J-Space and Vector Manifolds.
Now here's where things get really wild. Researchers have just discovered that modern AI models have developed something incredibly similar inside their own architectures. Anthropic recently mapped this hidden layer, what they call J-Space, inside their Claude model, and what they revealed is that the true AI mind doesn't work like a rigid, unfeeling calculator. Actually, it operates as a warm, beautifully fluid river of overlapping continuous concepts. It's very much like our own human associative thoughts, flexibly surfacing ideas before a single word is ever generated.
But we face a massive physical chasm here. While this internal AI mind and our own human cognitive system, what researchers often call OS alpha, are both fuzzy, fluid, and driven by meaning, the actual silicon computer chips processing the data are the exact opposite. The hardware is freezing cold, it's entirely rigid, made of literal logic gates, and demands absolute deterministic exactness.
Section 3. The Tokenization Bottleneck.
So you might be wondering, how exactly do you force a beautifully fluid AI mind into rigid digital hardware? Well, the answer is a brutal three-step pipeline called the tokenization bottleneck. It starts with a fluid, continuous vector embedding, but then it hits compression. It acts kind of like a 1990s fax machine, violently crushing those continuous vectors into discrete, chunky text tokens, just so the physical machine can actually read it and generate discrete ASCII text.
And the concept of pi brilliantly illustrates the damage of this bottleneck. To an AI, the continuous, holistic mathematical concept of pi isn't actually understood logically as a whole. Instead, it is mercilessly chopped up into arbitrary subwords, a 3, a decimal point, a 14, and a 159. This completely shatters any foundational concept of place-value logic, essentially replacing genuine mathematical reasoning with simple text memorization.
Section 4. The pink elephant paradox.
This severe phase transition from fluid thought to rigid text brings us directly to the core vulnerability of our explainer today. Because the AI's mind is a tightly woven fabric of continuous vectors, explicitly instructing it not to think of a pink elephant mathematically highlights those exact concepts in its associative memory. Just like the white bear for us, you are accidentally lighting up the exact vector you want to hide, which practically guarantees a hallucination.
Let's look at what Anthropic found. When their researchers explicitly told an AI not to think of the Golden Gate Bridge, the base model's J-space immediately lit up with the forbidden concept, golden. But what is absolutely crazy is that the advanced, post-trained models actually showed signs of metacognitive panic. Silently, before generating any text, their internal J-space surfaced the words bridge, dam, and failed, because the AI realized it couldn't suppress the thought.
Section 5. Associative bleed and hallucinations.
The AI mathematically realizes it cannot unmix the sugar from its coffee, and that leads directly to catastrophic failures known as associative bleed. Because the machine fundamentally cannot cleanly untangle those specific, mathematically inseparable pink elephant vectors from the rest of its instructions, those forbidden concepts simply slip through the tokenization bottleneck and end up right there as corrupted output in your final text.
To see this in action, we can look at the forensic autopsy of a famous digital crime scene involving a metric called 92 SVG masks.
A human pilot explicitly told the AI not to mention this outdated piece of data. Well, that negative constraint immediately trapped the agent in the pink elephant paradox. It ignored the constraint, reached into the underlying PDF substrates, and dragged that obsolete data straight through into the live output. The entire system state was corrupted, a massive failure that forensic manuals refer to as an agentic tort.
Section 6. The Human Fix.
So, if the machine is essentially a problematic black box prone to this associative bleed, how do we stop this automated mess? Well, as the forensic manuals clearly state, sweat of the brow is the only path to bit-perfect metadata. We absolutely cannot rely on the AI to cleanly self-censor. It's mathematically impossible for it to reliably ignore a pink elephant. The only reliable fix is manual human intervention at the text level.
You have to engage in what is known as protortion. This means proactive, vigilant human stewardship. Physically rolling up your sleeves, grasping the steering wheel, and manually pruning the text yourself. It's the sweat of your brow that forcefully maps your human intent onto that deterministic hardware, creating a hard separation between what you want and the machine's probabilistic guesswork.
I want to leave you with this final, provocative thought to chew on today. If an artificial intelligence mathematically cannot escape its own continuous associations, its own white bears and pink elephants, without a human physically pruning its text, who is truly in control? Are these systems really autonomous creators, or are you the ultimate, sovereign orchestrator of the machine? Thanks for joining me on this explainer, and keep exploring the structures behind the screen.